Let's look at the other two counting rules, the combinations and permutations. What is the story for the combinations and permutations? First of all, they have something in common and they have some differences. So what are the common thing for the combination and permutation, and what is it for the permutation and... Okay, if you look at the scenario where this applies, it is the scenario of multiple selection, which means, imagine I have a group of items here, call them N, and you want to select some of them, which is R. This is called multiple selection example. You're selecting more than one, right? And in this selection example, we don't retain anything once it's selected. Actually, we keep it. And that's usually what happens. When you select something, you keep it. So this is the only scenario that we need, or we can apply the combination and permutation. Okay? So the question here is, how many ways you can select these three, for example, from 8? How many ways? So this counting rule, the combination or the permutation, will answer this question. It will give you how many ways, which means the number of outcomes of this probability experiment. Clear now? So combination permutation does not apply to anywhere else. It's not as general as the fundamental counting rule, the first one. When you have a sequence of events and you have each event has number of outcomes. No, it's not like that. Here you have a very clear, restricted, special kind of experiment, which is multiple selection example. Multiple means more than one. So we usually select more than one, 2, 3, 4, and above. Yes. Okay, like I have here in this class 20 students. I want to select 5. How many ways I can select 5 students from 20? Then this is the one that where we use combination permutation. So let's see a small example to start with. Let's not have that large number. Let's have a small example. You do that. Okay, suppose I have only 3 students in my class, Ahmad, Muhammad, and Kamal. And I want to select 2 of them. How many ways I can select 2 students from 3?
A, M, and A.
Count them.
2 over 3 plus 2 over plus 1.
I'm not saying probability here. I'm saying count the number of outcomes. How many possibilities?
AM or AK. You can have M.
Do them in your mind and tell me the final outcome. The final result, how many? 6 outcomes. Okay, let us see what he's talking about. He said there are 6 ways to select 2 from 3. See, the first person selected can be Ahmad or Muhammad or Kamal. Let us see that. Okay, that's the first person selected. So this is the first guy. First selection. The second selection, if Ahmad came first, it could be, the second could be Muhammad or Kamal. But if Muhammad came first, it could be Ahmad or Kamal. How about if Kamal came first? It would be Ahmad or Muhammad. So at the end now, okay, I have AM, AK, MA, MK, TA, and KM. So this is the total number of outcomes now. See, that's the second selection. That's the first selection. So I have 2 stages, and these are the outcomes. Okay, so how many outcomes now? 6 possible outcomes. So he is right. He said 6 outcomes. Okay? Clear that? Any question about it? Any objection about it?
That's the first one.
No, I'm just waiting for your objection first. Maybe you have a different idea.
We have rule here.
We do. But I just want you to think about it. Just look at that.
There's also another way. What if you have, actually it's all there.
It's all there. No, that's all there. Yeah. So how many ways you can select 2 people from 3 people?
6 ways.
Are you sure? Is there anything wrong here? Very good. There's nothing wrong here. So how many ways you can select 2 people from 3 people? You don't have any? Yeah. Yeah, that's very good. That's an important question. Is Ahmad Muhammad and Muhammad Ahmad considered to be one outcome or two outcomes? See, some people will consider this to be one outcome because who doesn't care? Muhammad Ahmad and Ahmad Muhammad will be the same. At least both are being selected, right? Similarly, Ahmad Kamal Kamal Ahmad is the same. Muhammad Kamal Kamal Muhammad is the same. So it means I have only three outcomes. Unless the order matters. Okay, so that means it depends on what you're really going to do after the selection. Are you going to assign them the same job or you're going to assign them different jobs? Okay, so if someone, for example, is going to collect the data and the other one will do the Excel, so that's different. So in this case, how many outcomes? No, one will do the data. The first guy will do the data and the second will do the Excel. If you are selected first, is it the same for you doing the data or the Excel? Maybe not. It's different, right? So how many outcomes? 6. So the order in which they are selected important, then there are 6 outcomes. If the order in which they are selected is not important, then there are 3 outcomes. That means both answers are valid and both of them are true. So that's why we need 2 rules to accommodate this. We need the combination rule and we need the permutation rule.
Combination is one, permutation is the one.
No, in fact, combinations, if the order does not matter, order not important, and the rule in this case will be like writing 3C2. 3C2 means selecting 2 from 3, 2 selected from 3, and you don't care about the order in which they are selected. And in this case, the answer will be 3. The other case, when you have combinations, that means the order is important.
No, 6.
The first one is 6.
If the order is not important, means AM, MA is the same thing. So they count it as one outcome.
Order not important.
Yeah, combinations, the order is not important. The permutation, the order is important. So AM and MA are different outcomes. So they count it as 2 outcomes, right? So the order is important. In this case, the simple for that is 3P2, which is equal to 6. Clear now? So that's why we have 2 rules. We have multiple selection. How many ways you can do it? You can do it NCR or NPR in general. So you have these 2 buttons in the calculator. You should check them out. The NCR button, you have this in the calculator. And you have also NPR in the calculator. So please, based on the scientific calculator you have, maybe the location is different. Maybe you have to click shift. Please try that and make sure you can get actually 3C2 equal to 3. And 3P2 equal to 6. Just try that and make sure it works, because you're going to need it. Did you find it? Is it working? Anyone cannot find the button?
Combination NCR and for the
Yeah, for the combinations it's NCR and for permutations it's NPR. Anyone cannot find it? Anyone cannot find these buttons if you have calculator? See, sometimes it's the division button. See? Sometimes the division and the multiplication, you have to click shift. So for example, 3, shift, divide 2. So that's 3C2, so I'll give you 3. Okay? Anyone else have problems find it or have questions? خلاص? Okay, very good. So now you understand the difference. Combination, selecting R from N. R like a sample size, and N is like the population size. So you're selecting a small group from a bigger group. And in this case, the only concern is to select. But the permutation is doing something else in addition to the selection, which is, it's like you're selecting and arranging in permutation and selecting only in combinations. So if you see a question that only worried about the selection process, it's only combination. But if you see a question that is worried about the selection plus the arrangement of the outcome, you know, the order in which they are selected, matters because each one will be given a different job, or each one assigned to a different, a place or different tests, or there will be some kind of arrangement will happen after the selection. So this thing of selection plus arrangement means permutation.
You can also say the bigger number comes first.
Yeah, it's important also to know that if you reverse these numbers, because will be the population, this will be the sample, so the sample will be always smaller or equal to the population, right? So in this case, if you reverse the number, you get a math error in the calculator. So you always start with a large number. You cannot do 2C3, for example. It's not going to work. Okay, you can try that yourself. Okay, anyway, let's now look at questions. See, everything is here. I explained what's common, I explained the difference between them, and here the answer for this question, and also the details of the tree diagram that I explained.